Okay, let's look at an example for quiz 7, number 2. Alright, so you have a function f of x, which is x plus 4 over x. Right? So for part A, we want to find vertical asymptote and slant asymptote. Right, vertical asymptote is easy to find since there is x on the bottom. Right, so we set that equal to 0, so x equals 0 is the equation of the vertical asymptote. So I box that in. Right, for slant asymptote, you can see that say for large x value, you can see that 4 over x is very close to 0, because 4 divided by big number is close to 0. So which means that for large x value, f of x, which is x plus 4 over x, right? But 4 over x is almost 0, so this is very similar to just x, right? So slant asymptote is going to be y equals x. Y equals x, right? So that's the slant asymptote. Alright, then for part B, we need to find the local extrema, right? So local max and the local min, right? Unfortunately, the sign chart is already done up here, so we just have to follow this, right? So you can see that here, first derivative is positive, which means that the original function f is increasing on this interval, right? After that, it's decreasing because first derivative is negative, right? After that, it's still decreasing, so you have that, right? Then after that, it's increasing since the first derivative is positive, right? Which indicates that here at negative 2, we will have a local maximum, right? Right? At 0, there's nothing happen. It's actually function is not even defined at 0, right? But at x equals 2, since the decreasing turns into increasing, so we have a local minimum at x equal 2, right? So let's find let's write that. So local max. Let's see, we have to plug in negative 2 into the original function. So that will be negative 2, right? I'm plugging the original function, plus, right, 4 over negative 2, right? So that will give you, basically it's a negative 2 minus 2, so it's negative 4, right? So local maximum value is negative 4, so this is a local maximum, right? And the local minimum at occurs at x equals 2, so plug in x equal 2. You have 2 plus 4 divided by 2, right, which is going to be positive 4, and which is the local minimum, right? So we have that. All right. And part C, actually I forgot to put part C here, so I'm gonna put part C. Right, we're gonna use the given sign chart and the given information from here. Try to sketch the picture of y equals f of x. All right, so let's do that. All right, first thing, we can put vertical asymptote. X equals 0 is the y-axis, so it goes right on top of y-axis. It's kind of hard to see, right? So that's the our vertical asymptote. So indicate that vertical asymptote. All right. Then slant asymptote is y equals x. So that's going through the origin, and slope is 1. So I'll try my best to draw, let's see. So it's going to be y equals x. Looks like this. All right. So this is our slant asymptote. So I'm going to put slant asymptote here. All right. Then we have a local max and a local minimum. So local max occurs at -2. So I'll put, say, 1, 2. So here's -2. And this occurs at -4. So 1, 2, 3, 4. So here's -4. Right. So I'm gonna place a dot. Right. So that's where right here local max occurs. And also 2, 4, that's local minimum. So here is our 2, right? So go up 1, 2, 3, 4, right? So that's where our local minimum, right? Place a dot, all right? Then we have to look at the second derivative. You can see that the second derivative is negative before 0. Okay, so that means that it's a concave down. So concave down on this interval. All right. After that, it's second derivative positive. It's going to be concave upward. All right. Then we do our best to try to draw a picture. All right. So we have a horizontal asymptote here, and vertical it's a slant asymptote here, and it's a vertical asymptote there. Then we have to, right, increase turn into decreasing. Then you have a concave down shape, right? So this is going to be, so you have a horizontal, the slant asymptote here, slant asymptote here, and a vertical asymptote there, right? So it looks kind of like that, right? Then up here, it's decreasing turn into increasing, and a concave, I meant concave upward here, right? So you have a graph which looks like this, going down, concave upward, so that's the local min, and then you have a slant asymptote there, right? So that's the graph of y equals x plus 4 over x, right? That's it. I hope that this was clear.